So first off, just a little bit of introduction then. So today's going to be our final lesson on probability. Tomorrow we're going to be moving on to some like brand new exciting trigonometry. So that's going to be excellent. But right now we're going to do our final lesson on probability. We're not especially going to do anything new today because I think for most of you it would benefit you just to practice some more probability trees. So we're going to be working on some kind of exam style questions so you get used to the way things might come up in your GCSE. For those of you that already feel quite confident, so maybe you've been doing all of the questions, been doing the gold questions, getting everything right, I'm going to go through like some advanced examples involving algebra. That is quite difficult, so if you don't want to go on to the algebraic probabilities, that's absolutely okay. But if you'd like to challenge yourself, there will be the opportunity to do that in today's lesson. So, to start with then, this is what we work on for your main task. Okay, so year 10, this example then to help with your main task. Here we are told that Sean has a 0.6 chance of winning golf and a 0.45 chance of winning pool. So therefore, if he's got a 0.6 chance of winning, he's got a 0.4 chance of losing, because 1 minus 0.6 equals 0.4. Similarly, in terms of pool, if he's got a 0.45 chance of winning, his chance of losing is 0.55. And so we can fill in the rest of the tree. And often you can get 1 or 2 marks for filling in a tree correctly. Second stage of questions here. Find the probability of each of the following events. Sean wins golf and loses pool. Now that word "and" in probability is a clue that you are going to multiply. So the probability of winning golf is 0.6. The probability of losing pool is 0.55. So we multiply those two things, which gives an answer of 0.33. Just check that. Perfect. Next one, Sean wins golf and pool. So he wins them both. So winning golf is 0.6. Winning pool is 0.45. And so we multiply again, which is 0.27. Part 3, Sean loses golf and pool. So losing golf is 0.4. Losing pool is 0. Oh, that should say 55 there, sorry. Which is 0.22. And then finally, loses golf and wins pool. So losing golf is 0.4. Winning pool is 0.45, and we multiply. So doing that now is 0.18. Lovely. Final part of all of this question. So find the probability of each of the following events. He wins exactly 1 game. So there's several ways that this could happen. Either he could win and then lose, or he could lose and then win. I'm just going to write these options here. So the options are win, 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 lose, lose, win, lose, lose. So it's this option, win, lose, or this option, lose, win. And because it's this, or is your clue that we add together. So we need to do the probability of win, lose, which we worked out earlier, didn't we? Win and then lose was 0.33. Lose and then win was 0.18. And we add those two together to get our final answer of 0. Oh, I'm going to run out of space. 0.51. Question 2. Sean wins at least 1 game. So to win at least 1, you could win and then lose, you could lose and then win, or you could win and then win. So we add all of these options together. So win and then lose was 0.33. Lose and then win is 0.18. And then finally, win and then win is 0.27. So we add these options together because it's this or this or this, giving a final answer of 0.78. Oh. Next part, Sean loses at least one game. So to lose at least one, you could win and then lose. You could lose and then win. Or you could lose and then lose. So in terms of those options, win and then lose is 0.33. Oh, sorry, one moment. Lose and then win is 0.18. And lose and lose is 0.22. So we add these options together, we get a final answer of 0.73. The final one, Sean doesn't win both games. So the easiest way here is to think, well, the probability he does win both games is this option, which is also this option here. So the probability he does win both games, well, let me write in a colour you can actually see. So, oh, there we go. Probability of winning both is 0.7 is 0.27. So the probability of not winning both is 1, because that's the whole probability, take away 0.27, which is 0.73. Now at this point in year 10, most of you should make a start with the main task today. And if you're going through that and marking your answers and finding it quite straightforward, then watch the final part of the video, which is on challenge. Okay, so year 10, this is the challenge part of the videos. This is difficult. This is sort of, if you're aiming for like a grade 8 or so in your GCSE, this is the type of thing you need to be able to do. If this is too difficult for you right now, please do not panic. Just stick doing the main task. That's amazing. So here is our challenge question. What are we told? There are Y black socks and 5 white socks in a drawer. Josh takes at random 2 socks from the drawer. Probability of taking 1 white sock and 1 black sock is 6/11. And then all of a sudden we've got this thing here. Show that 3y squared minus 28y plus 60 equals 0. What? Right. First of all, we are not going to panic. This is step 1. Step 2. Well, this is like a probability tree question, isn't it? It's got a similar form. So let's draw our probability tree. This is the first sock, and this is the second sock. Lovely. And then this can be our black socks, white socks, black socks, white socks, black socks, white socks, and so on. And let's just remind ourselves of what all the different outcomes are. The outcomes are black, 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 white, white, black, or white, white. So then, what are we told? We are told there are Y black socks and 5 white socks. So how many socks there in total? Can anyone think through that? In total, there would be Y plus 5 socks. So then here, originally there were Y black socks and there were Y plus 5 socks in total. Down here, in terms of white socks, there were originally Y plus 5 socks, and 5 of them were white. Now, next bit's a little bit more complicated, but he's taken out a sock from the drawer, hasn't he, at this stage? So there's going to be 1 less sock left in the drawer. So if there were Y plus 5 and he takes 1 out, there's only Y plus 4 left. Oh, this is tricky. So, this is him taking out a black sock. There were Y black socks, he takes 1 out, so there are now Y minus 1. Now, he's taken out a black sock, but there's still the same number of white socks, so there are still 5 white socks in the drawer. Down here, he's taken out a white sock, so there are still Y black socks in the drawer, but he's taken out a white sock, so there's only 4 of those left. Whew. Okay, so then we are told, blah, 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 the probability he takes 1 white and 1 black is 6/11. So there's two different ways, aren't there, that he can take out a white and a black sock. He can either take out white then black, or he can take out black then white. So let's work these out then. So black then white, we would work out by doing y over y plus 5 times by 5 over y plus 4. Okay. Now, in terms of writing that for now, what will we write? On the numerator, we get 5y. And on the denominator, I am going to expand out. So I'm going to put these in brackets and expand this set of brackets out, which gives y squared. And then it would give plus 5y plus 4y, which is plus 9y, plus 20. Here, if it's white and then black, that's going to be 5 over y plus 5 times y over y plus 4, which also gives 5y over y squared plus 9y plus 20. Now, I said earlier, when we've got those two different probabilities, white and then black, or black and then white, we add them together. So when I add these two fractions together, I am going to get this. I'm going to get 10y, because 5y plus 5y is 10y. My denominator is still going to be y squared plus 9y plus 20. And then what are we told about that? We are told the probability of that is, I didn't mean to do that, I just meant to highlight, and I'm not on my highlighter, is 6 over 11. So therefore, this y squared plus this 10y, this bit here, equals 6 over 11. These two things are the same as each other. And now what we can do is we can cross multiply. So when I cross multiply, these two things get multiplied together and these two things get multiplied together. Now I've not got a whole load of space, which is annoying. So I'm just going to write down here for the minute. But these two things get multiplied together. So on the left hand side, I end up with 110y. And on the right hand side, I end up with, well, 6 times y squared, 6y squared. 6 times 9y is 54y. And 6 times 20 is 120. Okay, so we've got, this is beginning to look a little bit more like this thing, but still not quite. Okay, so let's take away 110y from both sides. So then we get 6y squared. Now 54, take away 110 is minus 56. Like that. And this is really almost now what we're trying to get to, because what we're trying to get to now is just this. So to get from this to what it said in the question, all we need to do is divide by 2. And voila, we have got to what we wanted to get to. I'm going to show you part B on the next slide. Okay, so year 10, if you are still with me, well done. This is super, super tricky. You're doing amazingly. So find the probability that Joshua takes 2 black socks. Right, so 2 black socks is going to be up here somewhere. So to find the two probabilities of black, I could do y over y plus 5 times by y minus 1 over y plus 4. And that's all good and true, and that would give me the answer, but I want a numerical answer. And the way I can do that is I can solve 3y squared minus 28y plus 60 equals 0. So what type of equation is this? This is a quadratic equation, isn't it? Because it's got a y squared in. Now, because this is quite a difficult quadratic, and this would be a calculator question, we are going to solve it using the quadratic formula. So many steps here. The quadratic formula is this. And in this case, A is 3, B is minus 28, and C is 60. So into my calculator, I'm going to type the following. And when I put that into my calculator, I'm just going to do that now. I get two different solutions. Oh, I've typed it in wrong. Sorry, 1 sec. I get two different solutions. One of which is x equals 6. The other one of which is x equals 3.3 recurring. Now, in this case, actually we're solving in terms of y, aren't we? So this is what y equals. Y equals 6 or y equals 3.3. What must y be? Well, y is the number of socks. You can't have 3.3 recurring socks. That would be weird. So y is the number 6. So we've got the y is the number 6. The rest of it's reasonably straightforward. If y is the number 6, I'm going to substitute that into here. So I get 6 over 6 plus 5 times by 6 minus 1 over 6 plus 4, which is 6 over 11 times 5 over 10. I'm working that out on my calculator. Gives a final answer of 3/11. If you've kept up with all of that, Year 10, that's absolutely fantastic. Have a go at the challenge questions that I've highlighted. If this has been overwhelming and too much, do not panic. This is like super difficult. I hope the rest of your probability work goes well. As ever, please just drop me an email with any questions. Good luck.